আজকে আমরা going to start some aspects of partial differential equation which you have in your syllabus of WBSU. Is a second paper, mathematics general. So last few lectures we have come across how to formulate partial differential equation. So we have removed arbitrary parameters, we have removed or eliminated arbitrary functions and formulate the partial differential equation. Now today we move forward, and in this class or in this lecture I am going to introduce particularly one method that is Lagrange's method. By this method is a very good method to solve any partial differential equation of obviously first order and linear, or you can say quasi-linear. So before going into that, I'll explain or I'll make you clear what do you mean by this linear thing, linear partial differential equation or quasi-linear partial differential equation. But you should know that most of the partial differential equations have no solution. So I have just mentioned a few differential equations which are of tremendous importance in physics or in other branches of science. These are extremely famous equations. I think you may have come across these equations or you will come across these things. The first one I have mentioned is wave equation. You can clearly see the wave equation. Equation is like this: c square del u equals to del 2u del t2, where this thing is equals to Laplacian. Laplacian means this thing. Okay, so it indicates the propagation of wave. Those can be anything. It can be water wave or sound wave, anything. The propagation of any wave is formulated or is depicted by this equation, this mathematical equation. Maybe you have come across heat equation. Heat equation is of this form: alpha del u. This is actually Laplacian operator. Laplacian of u is equals to del u del t. This is a conduction of heat in medium. How heat is conducted, this is formulated by this equation. Another is Laplace equation, where this Laplacian is equals to 0. Another equation is Schrodinger equation. This Schrodinger equation is very much, or it is the backbone of quantum mechanics. It is a propagation or wave function equation. This Schrodinger equation gives the wave equation of quantum mechanics. The formation or propagation of wave in time, you can at once say from this equation. There is another equation I am also mentioning it here. This is KdV equation. So what is KdV equation? KdV equation is another equation which is non-linear. These all equations I have mentioned earlier are linear, but this equation is non-linear. But although this is non-linear, this equation have exact solution. Very few non-linear PDE has solution. KdV is one of them. It has solution, and I think the most famous equations are this Maxwell's equation. Set of 4 equations are there. I think you all know. This is specify the magnetic field and electric field. These are all depicted by these 4 equations. This is the backbone of current or modern physics. So these are all equations from example perspective. These are popular examples of partial differential equations. So now our task is to classify differential equation, partial differential equation with respect to linearity. and our thrust is to classify first order PD. So we are going to classify how many types of first order PDE can we see. The first one is quasi-linear, the second one is semi-linear, third one is linear, and the last one is non-linear. So what do you mean by quasi-linear first order PDE? So it's very clear. Quasi-linear first order PDE is obviously differential equation which can be written in this form. See, this is the first order PDE because this is ux and this is uy. They are all of first order and no higher order terms are there, and these coefficients a, b, and this constant the right hand side term c, they are all functions of x, y, and u. Okay, so whenever any first order PDE can be written in this form, this PDE, first order PDE, is called quasi-linear PDE. Semi-linear PDE is a particular type of quasi-linear where you see the coefficient a and b, these two coefficients has previous dependence on u, but this time it has no dependence on u, but the term c, the right hand term, may have some connection with u. Maybe some functions of u can be there, but not here and here. Linear PDE is that type of PDE where you see the right hand side part, which is a function of x, y, and u. This c part is not a z but u. We are taking that dependent variable u, not z. Yeah? So this thing can be written as c0 of xy of u plus c1 of xy. So this thing can be written as a linear function of u. So whenever any semi-linear first order PDE, the right hand side, this c part, can be written in this way, then this semi-linear first order PDE becomes a linear PDE. Okay, so I am repeating again, this is a very important thing. So mostly we will discuss this quasi-linear PDE, and obviously this semi-linear and linear, they are all special cases of this quasi-linear PDE. Quasi-linear PDE, by quasi-linear PDE we mean, or we mean this thing, this differential equation, this partial differential equation, or the coefficients of ux and uy. If you have difficulty in understanding, ux by ux we mean del u del x, and uy is mean del u del y. Okay, so by this this a, b, and c, they are all functions of x, y, and u. This differential equation is called quasi-linear PDE. Whenever this quasi-linear PDE, the coefficients a and b can be, or they are only functions of x and y, not u. There is no u. Then this equation becomes semi-linear, and we again move one step further, and whenever this c part, the c part can have dependence on u in semi-linear part, but whenever this u dependence can be written in this way, this dependence is linear on u. Okay, so then this semi-linear PDE, this is semi, you can see the number is 2, this is semi-linear, this is quasi, and this is linear. So Quasi-linear becomes semi-linear whenever a and b becomes function of x and y only. Semi-linear becomes linear whenever this c part becomes, or you can write this c part this way, then it becomes linear PD. And the last part I have not mentioned, this is non-linear. Obviously non-linear means there may be some non-linear dependency. It's better to give some examples. So for example, non-linear wave equation, you can see u is a function of x and t, so this is del u del x and del u del t, and this thing u plus c equals to 0. This is a non-linear wave equation, and its solution you can see is this thing. So this is a non-linear differential equation. So the one thing you should note, that this classification is just a branding of differential equation or partial differential equation. It doesn't do anything, or it doesn't help you to solve that particular differential equation. Our aim will be to solve the particular differential equation. There are some methods. So now we are going to give you the method. Basically, two methods are there in your syllabus. One is Lagrange method and another is Chapman's method. By these two methods, you can solve partial differential equation. The Lagrange method will help you to solve quasi-linear PDE, and Chapman's method will give another way of solving. You can solve also non-linear PDE by Chapman's method.